We're discussing we are discussing metals and non-metals. Okay, metals and non-metals. Non-metals. Okay. So, dear students, what we need to study in this chapter is, first of all, physical properties. You have studied about metals and non-metals, that with the exceptions. That let me discuss the topics first of all. You need to help me that which topics you have studied properly. Okay. One is the physical properties of matter. Physical properties of metals. Okay. Second one is chemical properties of metal. Okay. Have you studied both of them, or means just like we have in the physical properties, what we usually study that metals are sonorous, they have high melting and boiling point, they have high low ionization energy. Okay, and in the chemical properties, we generally study that metals when react with acids, they gives you salt and hydrogen gas. Metals when react with metal carbonate when react with acid, they gives this. So have you studied that one or not? Tell me. Abir, Nauful, Shoaib, Shreya, tell me, beta. No one.
Sir, I was not there in the last class. It's my first class with you.
Okay, you was not there in the previous class.
I wasn't there.
Okay. So what have you studied metallurgy chapter or not? No, you have not studied that. So wait a minute.
Sir.
Let me find out the slide. Wait a minute. Just give me a 1 minute. Okay. So here it is. So let's start with the metals and non-metals. Okay. So what actually the metals is? This is my first class now. I was just taking the class. I am the HOD of this department, and I am just started taking your class from previous some couple of days. So I don't remember which batch I taught the previously one. So this is my first class with you now? But is it
Yes,
the second?
sir.
Or is it the
Yeah.
second one? Yeah, it is the first one. Okay. So let's study first. What is metals and non-metals? Okay. So first of all, let me discuss that what are metals. Okay. So in there are so many types of substance that we see around us. Okay, like we see a table, we see a chair. Okay, we see fan along it. So all of them are made up of some substances, matter. Okay, and generally matters, we have divided the matters into three. We have divided matter. If I'm going to explain you this one, that we have divided matters into two main parts. Okay, one is the elements. It's pure and impure substance that we have studied. Okay, solid, liquid, and gases is the other thing. But normally we have divided the matters around it that we see that in the form of elements, compound, and mixtures. Okay, and mixtures that you have also studied in the 9th standard. So these elements, compounds, what are compounds? Compounds are made up of one or more than one element. Means when two or more elements chemically combine together, they form a compound. You have this one studied in the previous classes also. It's like H2O, CaO, calcium carbonate. Okay, this one is compound. So what is element? Element is a substance that consists of one kind of atoms. Okay, let me explain you this one more betterly. That what is an element? Let's discuss with them. Okay, what is an element? Okay, so let's discuss that elements. We can say that an element is a substance that consists of only one kind of atoms. Okay, I'm going to explain you that when we will do the questions regarding to this one also. Okay, so let's first understood that what is an element. And okay, what is an element? Element is substance that consists of only one kinds of atom. Means if we are going to have if I'm going to take an example of copper. Okay, like I'm just taking this example of copper. So all the atoms of copper are similar to each other. Whether you have taken the copper from America, you have taken the copper from London, Paris, Hong Kong, Russia, anywhere. if I'm saying that this strip is made up of copper, then the atoms of copper will be similar. Similarly, if I'm saying that I've just taken another strip. Okay. So I will say that this is an example of silver. This is a strip of silver. So all the atoms of silver will be similar to each other. But the atoms of copper is different from silver. All copper atoms are same. All silver atoms are same. But the atoms of silver and copper are different. Okay. This is copper. They are different. So again, what I need to say that an element is a substance. I'm not talking about the elements. An element is a substance that consists of only one kinds of atom, and we can simply say that different elements have different kinds of atom. Note it down fast. Note it down.
Noted, sir.
Noted. Every other.
Sir, done, yes.
Noted down. Okay.
Done, sir.
Done. Okay. So if I'm considering these elements, okay, so what is the difference? For example, if I'm taking an atom of hydrogen atom and helium atom, and this is oxygen gas, oxygen atom, and this one is nitrogen atom. Okay, hydrogen atom is the atom which is going to have nucleus at the center and one electron only. And helium is the atom that is going to have 2 electrons only. Okay. And oxygen is the atom which is going to have nucleus at the center, 2 electron in the first shell, and 6 electron in the other shell. And nitrogen is the atom that is going to have nucleus at the center, 2 electron in the first shell, and 5 electrons, 1, 2, 3, 4, 5. 2, 5, 2, 6, only one, and only 2. Okay. So you can consider here that hydrogen and helium are different only but with 1 electrons. And hydrogen is very reactive and helium is not reactive. It behaves as an inert gas. It does not react readily. It does not react. Similarly, you see that this nitrogen atom and oxygen atom is differ only by with 1 electron. Here it is 6 electrons present and here it is 5 electrons present. So this is the number of electrons that make the different atom different. The number of electrons, if the number of electrons in atoms are different, they are showing different properties. They will be different in characteristic. They will be going to have different melting and boiling point. They will be different in characteristic. They will be means you understood now that nitrogen, we cannot inhale the nitrogen, but we can inhale the oxygen. Oxygen is useful for us, but nitrogen is useful because it helps in making synthesizing protein and other stuff. But we cannot inhale the nitrogen gas. It does not help us in burning of glucose and produce and help in the production of energy. No, we cannot. Just the difference in the atom is making. If I transfer one electron to this nitrogen atom, it will become the oxygen atom. So what is that thing that is making different element different? That is the number of electrons. Got it? Everybody understood? Abir, Nawful, Shoaib, Shreya.
Yes, sir.
Understood? Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. Let's move further. Now, if I'm just considering this one, let understood beta. This is very important. Okay. Now I'm saying that except the hydrogen that is going to have 1 electron, and that is helium that is going to have 2 electrons. If I'm saying that other elements, like for example, if I'm writing here hydrogen, helium, lithium, beryllium, boron, okay, then carbon, then nitrogen, oxygen, fluorine, okay, then argon, sorry, neon, then I'm going to write here sodium, okay, magnesium, then aluminium, then silicon, okay, then sulfur, phosphorus, Okay, then so if I'm writing this one, the electronic configuration of hydrogen is 1, the helium is 2, the lithium is 2, 1, beryllium is 2, 2, boron is 2, 3, carbon is 2, 4, nitrogen is 2, 5, oxygen is 2, 6, fluorine is 2, 7, neon is 2, 8, okay, sodium is 2, 8, 1, magnesium is 2, 8. That you have studied this one in previous class also, okay, in the 9th standard. If you have not studied, let it be, I will teach you. This is 283, this is 284, this is 285, 286, sulfur is 286. So here is phosphorus comes before sulfur. Phosphorus comes before sulfur. Phosphorus, then sulfur. This is 285, then this is 286, and then one is 287 is chlorine, 287 chlorine, and then again argon will comes to 88. Okay, so if except this hydrogen and helium, generally metals have 1, 2, or 3 electron in their outermost shell. Generally metals have 1, 2, and 3 electrons in their outermost shell. For example, if I'm considering here, so this one is metal, this one is metal, this one is metal. Then again, this one is metal, this one is metal, this one is metal. And non-metal is going to have 4, 5, 6, and 7. This is not a non-metal. This is 8 hai to nahi hoga, okay. Then it one is again, we should move towards this one. Okay, this one is non-metal, this one is non-metal, this one is non-metal, this one is non-metal. Okay. So except hydrogen and helium, that is going to have 1 and 2. What are metals? Metals are those elements, those atoms, or we can say that those elements that are going to have 1, 2, or 3 electron in their outermost shell will be considered as metal. Others like that is going to have 4, 5, 6, or 7 electron in their outermost shell, then they will not be considered as metal, they will be considered as non-metal. Okay, so we have divided the metals, elements into broadly 2 categories. Elements into broadly 2 categories. One is the metal. There is metalloids also, but we because we are just studying metals and non-metal, so I'm just dividing it into 2 parts. One is metal and non-metal. One is metal, another one is non-metals. Okay, so now you understood that what is the major definitions of metals and non-metal. That metals are those elements that is going to have 1 or 2 or 3 electron in their outermost shell, except hydrogen and helium. And non-metals are those atoms that is going to have 4, 5, 6, or 7 electron in their outermost shell. Now you understood?
Yes, sir.
Everyone, Abir,
Yes, sir.
Tejasvi, Shweb.
Yes, sir.
Okay, okay. So please, here is this one, and please write it down. This you have studied or not? This one, I'm just going to start this chapter from the beginning. So how many classes have you done with this chapter, metals and non-metals? May I know? Tejasvi, tell me.
Sir, we have done 3 classes.
3 classes. Okay. So have you done the chemical properties of ionic compounds? No, sorry, properties of ionic compounds and formation of ionic bond?
We just started with it.
You just started with this one. Okay. So let's start this one. Okay, better. Do this one, then write it down. Write it down. There are 117 elemental known, and we have divided the into elements into 3 types. One is metal, metalloids, and non-metals. Okay. Now, note it down. Yeah, these are the elements generally have 1, 2, or 3 electron in their outermost shell, except hydrogen and helium. Okay. Now, let me explain you one more thing, that metals are those substances that can easily lose electrons. Why? Why metal easily lose electrons? Let me check. That I have teach you here that this one is the electronic configuration that I have written here. Okay, that you are very much familiar that everyone in the universe wants the stability. Everyone wants a good job, a good house, a good car, and a good learning assets. Okay, so in a similar way, everything in the universe wants stability. Wants what they want? Tell me. They want stability. In chemistry is all about stability. Whatever we are just studying in chemistry that elements are, if the elements are making bond, if the bonds are broken, why they are broken? In order to attain stability. The simple reason is in order to attain stability. So let me explain you one thing here, that this one helium that I'm marking you here, helium, neon, and argon. Argon will comes after chlorine, that is argon, that is going to have 288 electronic configuration. Okay. All the other elements except helium, neon, and argon wants the stable electronic configuration to the nearest noble gas. For example, fluorine will like to come in the electronic configuration of 288. So because it is having 287, then it will borrow one electron from somewhere. Oxygen will also want to come into the electronic configuration of 288. And similarly, nitrogen will also want. So what we learn in the chemistry is that some element loses electron, some element gain electrons, and some element shares the electrons in order to attain this stability to the nearest noble gas. To the, tell me beta, to the nearest noble gas. For example, hydrogen will like to have the electronic configuration of helium, that is 2. Okay, like lithium will like to have the electronic configuration like helium, so it will lose one electron. Beryllium will also lose one electron, and boron will also lose one electron. Rather than gaining 5 in order to have this electronic configuration 2,8, boron will lose electrons. Okay, similarly, nitrogen will do not lose 5 electrons, it will gain only 3, because if it lose 5, the large amount of energy will be required to lose electron. So it will borrow 3 electrons. It will borrow 2 electrons. It will borrow 1 electron. So some elements loses electrons, some elements gain electrons. So those which loses electrons are called metals. Why? Because they have 1, 2, and 3. They can easily lose 1, 2, or 3 electrons in their outermost shell. But in non-metals, they have 4, 5, 6, 7 in their outermost shell. So it will require only 1 in order to make 8. It will require only 2 in order to make 8. It will require only 3 in order to make 8. And it will share. The 4, in the case of 4, it neither gain nor lose its share. And sharing is also comes under non-metal category. Okay, sharing of electrons. Okay. So what is the main criteria? What does metal do? Metal generally loses electron. Okay, understood? Understood?
Yes, sir. Yes, sir.
Metals generally loses electron because they have 1, 2, or 3 electron in their outermost shell. So they can easily lose electron rather than gaining. If sodium is going to have 2, 8, 1 electronic configuration, so it will lose easily 1 electron rather than gaining 7 in order to make 8. So it will not gain 8, 7. It will lose 1. It's like magnesium 282, so it will lose 2 in order to become 2, 8. Okay. So metal loses electrons while non-metals gains electrons. Okay. And when the electrons is being lost by an atom, it becomes positively charged. So metals become positively charged when they become, atoms become positively charged when they lose 1 electron. For example, this is sodium, 281 electronic configuration, sodium solid, but when it lose 1 electron, and it will become Na1 positive, and when lose 1 electron. So it is going to have 28 electronic configuration. Now you need to understand here that what is the difference between this one and this one. Now the metals with positively charged, the atoms with positive charge are called anion. Okay. Cation. Positively charged are called cations. Okay. And cations means this ions are of 2 types. One is cation.
Cations and anions.
Very good. And anions. Anions is negatively charged and cation is positively charged. So like take an example of chlorine. Chlorine is going to have 287 electronic configuration. So what will it do? In order to attain the stability, it will gain 1
It will
electron.
gain 1.
and it will form Cl negative ion. Okay, so this is the electronic configuration of 288. So since the non-metals gain electron, they form negatively charged anion.
Anions.
Very, very good. Okay, so now write it down that we have, okay, that they lose electrons from and form electropositive ions, we call it cations. They have low ionization enthalpy. What is ionization enthalpy? We'll discuss. And let's move to this one. That non-metals generally have 4 to 7 electrons in their outermost shell. They generally gain electron and form electronegative ions. They have low electron gain enthalpy. And what are metallites? That shows both properties of metals and non-metals. Okay, please write it down. When you're done, please let me know. Okay.
Sir, what is
Sir,
the last point of non-metals? They have low.
Electron gain enthalpy. Electron gain enthalpy.
sir,
Yes. Noted, sir.
Everyone, other?
Yes, sir.
Okay.
Yes, sir.
Now, okay, Shreya. Everyone, Tejasvi? Have you written better?
Yes, sir, done.
Okay, let's move further. Let's move. So let's discuss that what is ionization energy and why it is being required. What is an ionization energy? Okay, discuss this is an important or sometime it is being asked in the competitive exams. Okay. So what is an ionization enthalpy? What is ionization enthalpy? That ionization energy is that energy, enthalpy or energy is same thing. Okay. In chemistry, energy is being replaced by, or the word we use in place of energy is enthalpy. Okay. So what is ionization enthalpy? So we can simply say that it is the amount of energy required to remove an electron. It is the amount of energy required to remove an electron from an outermost shell of an isolated gaseous atom. What does this mean? What does this mean? And what is ionization energy? That metals, since metals can easily donate their electrons, they have low ionization energy. Why? Because this is, let's take an example of sodium. This is 281. What does sodium want? Sodium wants a stability. So it will like to lose one electron and become Na positive with 280 and will lose one electron. So according to the chemistry, in a standard term, that what is the amount of energy required to remove this electron? That will be considered as ionization energy. But we have to bring everything in the standard form. We have to bring everything in the standard form. What that standard form criteria is being satisfied or is being discussed, or we can simply say that what is that standard criteria? That ऐसा तो नहीं है, मतलब we can simply say that if I'm just having the chlorine gas Cl2 chlorine gas and we are removing one electron from it, okay, and if I'm having some gaseous substance like hydrogen and we are removing one electron from it, okay, one electron from it and making it hydrogen positive. So all of them is not going to have the same energy. They have different energy. So what is that ionization energy? Let me explain you one more time. That what is that ionization energy? It is the amount of energy required to remove an electron. What is that first condition? An electron. The electron number should be 1. An electron from the outermost shell, not from the innermost. If there are 2 electrons in the inner shell, and there are 4 electron or 3 electron from the inner shell. So if I'm removing this electron, so that energy will be calculated. From an isolated, means that atom should not be in the contact with other atoms. It should be isolated form. From an isolated gaseous atom, it should not be in solid state. For example, if I'm going to calculate the ionization energy of sodium, then first of all, I need to bring this sodium solid into sodium gas. Whatever the energy is being used in this one, it will not be calculated in the ionization energy. What is that energy? What is ionization energy? It is the amount of energy required to remove. It is the amount of energy required to remove an electron from an isolated gaseous atom. Okay. Amount of energy required to remove an isolated gaseous atom. Got it? So when it comes in the in gas state, now the energy is being used, that will be considered as ionization energy. So what is ionization energy? It is the amount of energy required every time we need to give the energy. Ionization energy is always endothermic process. It means removing of electron is always endothermic process, and we need to supply the energy. So what is ionization energy? Tell me. It is the amount of energy required
to remove an electron from the outermost shell, which is isolated gaseous atom.
Okay, very good. Of an isolated gaseous atom. For example, this I'm taking this sodium solid, and if I'm giving and converting into gas, so whatever this energy is being used, it is not considered in the ionization energy. Now, if it is in gaseous state, then the amount of energy is required to remove an electron, that will be considered as ionization energy. And it is always an endothermic process because energy is being supplied. So it is always positive. Positive means that we are doing endothermic process. Okay. So write it down, please. What is ionization energy?
Yes, done, sir.
Done. And it is
Yes, sir.
always an endothermic process. It is always an endothermic process. Got it? Every other students? Nawful,
Done, sir.
Shoaib, Shreya,
Yes, sir.
Tejasvi. Okay, very good. Very good.
Done,
let's
sir.
move- Okay, very good. Very good. Let's move further. Now let's move towards the physical properties of metals. What is we are just discussing that what are the physical properties of metals? Have you been discussed that what are the exceptions, and does ma'am discuss it with you or not? Physical properties of metal, that metals are they have high melting and boiling point. Have you been discussed with this one or not?
Yes, sir. We have discussed it.
Okay, so do you know the exceptions, that which metal, name the metal which is going to have very low melting and boiling point? They can easily melt at room temperature. Do you know that? No, let's start. That you know that metals are very hard, they can conduct electricity, okay, and they have very high melting and boiling point. They are solid at room temperature generally. That the examination, it is not being asked that metals are hard. They will ask which metal is soft. They will not say metals have high melting and boiling point. They will ask which metals have low melting and boiling point. Okay, metals are generally high densities. Which metal have low density? So they will ask the exceptions. So here I have written some exceptions here, that some physical properties of metals. I'm not writing each and everything because you know that metals are good conductor of electricity. They can conduct electricity. That are high temp. They have high melting and boiling point. I'm just writing here exceptions. That they have high density. They generally have high density, and the highest one is of iridium. Iridium is a metal which is going to have highest density. Okay, and that is of 2.25 gram per centimeter cube. Okay, and lithium, the lowest one, that is going to have 0.5 gram per centimeter cube. Got it? Iridium has the highest density, that is of 2.25 gram per centimeter cube, and lithium with the lowest density, that is going to have 0.5 gram per centimeter. That means lithium is the lowest. If I'm going to make a cube of 1 centimeter, 1 centimeter length, 1 centimeter breadth, 1 centimeter height. If I made it of this with iridium, then it will be the heaviest one, and that will weight of 2.25 gram. And if I make the same cube with length, breadth, and height of 1 centimeter, then this cube will weight of 0.5 gram if it is made up of 0.5 gram if it is made up of lithium.
Lithium. Yes.
Okay. So do you understand that lithium has the lowest density? Okay, Li.
Yes, sir.
Now moving towards next one is high melting and boiling points. High melting and boiling points. Generally, metals have very high melting and boiling point. Highest is of tungsten, and that is tungsten. The symbol of tungsten is W. Like we have sodium Na, carbon C for carbon. Like the same for tungsten, we have W, and it is the highest melting and boiling points. Can you know? Can you give me the example where tungsten is being used? The metal where we use tungsten. Can you give me the example of that substance or that article or where we use tungsten metal? No. Okay. Anybody? Shweb? Shreya? She is saying, sir, can you please clear the doubt that it is said that first shell can hold only 2 electrons, but they can make bond more than 2 like. First shell can hold only 2 electrons. The maximum they can have. But they can make bond more than of 2 likes. Yeah, I'm going to explain this one. I will explain you when we're going to discuss the ionic compounds. So let me discuss. Let first come to this point. After this one,
So tungsten is used to melt the metals.
No, it is not used to melt metal. It is used in the bulb filaments. It is used in bulb filaments. Bulb, you know, bulb glow with a very high, okay, with a high temperature. But this filament is made up of tungsten that do not melt. Why it does not melt? Because it glows very red hot, but does not melt. Why? Because it has very high melting point.
High boiling point.
Next one is, there are 2 metals, that is gallium and cesium. That is gallium and cesium are the 2 metals that is going to have very low melting point. Even if you put it on palm, and you rub it, it will melt. Gallium will melt. Why? Because the body temperature of our body temperature is 37 degrees Celsius normally, and that of gallium and cesium is approximately 25 degrees Celsius temperature. So when you melt it, when you put it on your palm, then it will start melting. So gallium and cesium are the 2 metals that is going to have low melting point. Okay. And that is when you kept it on palm, it will get melted. Okay. And we can simply say that mercury is another metal that is always that is liquid at room temperature. Okay. So generally solids, metals are generally solids. But mercury is the liquid at room temperature. Mercury is the liquid at room temperature. Mercury is the only element that is liquid at the room temperature. Okay. Metals are generally shiny. Example, silver. Silver is the most shiny metal. This is being asked so many times in examination. Most of the question being asked from this point. Okay, that which metal is very shiny, which metal conducts very. Okay. Let's move to the next one is that is malleable. Malleable means that they can be hammered into thin sheet. When you start hammering that one, like wood, if you start hammering wood will break into pieces. But metals have a very good characteristic that their atoms get arranged themselves because the force of attraction is very high, that it does not let the metal broke. And when you start hammering, the metal will shift themselves into thin sheet. Okay, so metals are malleable, that they can be drawn into thin sheet, and they are tactile also, that they can be drawn into thin wire. Okay, so ductility and malleability, I've written here that metals can be drawn into thin sheets, and ductile means they can be drawn into wire. Actually, most malleable metal is gold. 1 gram of gold. From 1 gram of gold, you can extract the 2 kilometer long wire. Okay, so gold is very ductile. Okay, 1 gram of gold can be drawn into a wire with length of 2 kilometer approximately. Okay. And they are hard. Means metals are generally hard, but there are some alkali metals. And what are alkali metals? you have studied, you have seen the table. The periodic table you have seen, all of them you have seen. I am sure that there is no one in the class who have not seen the periodic table. Okay, there are some groups in these tables. Okay, there are some groups. Okay, so there's the first group. First group here it is hydrogen. In some periodic table, hydrogen is written here. It is neither metal, non-metal, neither metal, non-metal. Okay, so we can simply say that here it is lithium, sodium, potassium, cesium. They are the first group elements are called alkali metal. This is the first group elements. Okay, that lithium, sodium, potassium, cesium. Okay, they are called alkali metals. Alkali metals. Okay, they are called alkali metals. Why? Why they are called alkali metals? What is the reason behind this? That their oxides is water soluble. Metal oxides are basic in nature. You know what are alkali? सबसे पहले अगर मैं बात करूं, what is alkali? What is alkali? Alkali is soluble base. Soluble base. Soluble base. And those bases that are soluble in water are called alkali. Okay. So when you have Na2 and when you dissolve in water, it will form NaOH. Okay. So we can simply say that their basic oxides is soluble in water. This can easily dissolve. Like if I am having a aluminium, Al2O3 oxide, when you give it water, okay, then it will not dissolve into it. This will not give you Al2, OH whole thrice. It will not give it to you. This one. It will not give it to you. Means this is not a solvent. Aluminium is not an alkali metal. Lithium oxide, sodium oxide, potassium oxide, cesium oxides are soluble in water. So they can easily dissolve in water. And if they can easily dissolve in water, so we can simply say that they are soluble in water. And since they are soluble in water, they are any base, metal oxides are basic in nature. And those oxide, those base means oxide, which are soluble in water are called alkali. We called it alkali. So these sodium, potassium, cesium, and lithium are called alkali metals. Now you understood what are alkali metals? Understood, everybody?
Yes, sir.
Okay. What are
Yes,
alkali
sir.
metals? Okay. Those metals that are soluble in those metal oxides that are soluble in water, they are called they form alkali base. Okay, and since the first group elements are soluble, their oxides are soluble in water, so they are called alkali metals. So metals are generally hard, they are hard, but alkali metals like sodium, potassium are soft. They can be easily cut with the help of knife. They can be easily cut with the help of knife. Okay, good. Have you written?
Yes, sir. Noted.
Everyone?
Yes,
Yes,
sir.
sir.
Oh, you are writing very fast. Tejasvi, Shweb, Shreya, written?
Yes, sir. Done.
Okay. Actually, I'm not familiar with your voice right now, so I am not able to understand who is answering. It will take 4 to 5 class, and I will be able to determine that who is saying yes, who is not. Okay. So let's move to the physical properties of non-metals. You have studied this one. Oh, let's discuss the doubt of Shreya. Shreya was saying something, so let's discuss the doubt of Shreya first. Okay. She was saying, sir, can you please explain the
Sir,
doubt?
my name is Shreyas.
Oh, Shreyash. Oh, I was saying Shreya. Oh, good. Shreyash. Okay, Shreyash. Let me explain you that you were having a doubt that the
Yes,
first
sir.
shell can hold only 2 electrons, but then they make bond for more than 2 like atoms. Why they make 2, 3, 4, 5, 6? What you're saying that they can only hold 2 electrons in their outermost shell. For example,
But
I'm
sir,
saying
but sir, while making a bond, they make bond more than with two, like 2, 4, 6, 8, 10, or even sometimes 12.
yeah. Actually, this is not the case of the first shell. Actually, this one is the first shell, and it can hold maximum 2 electrons. Okay. The second shell
Yes, sir.
can hold maximum 8 electron. 1, 2, 3, 4, 5. Let me check. Let me give you. This one is first shell K, and the maximum electron that it can have is 2. Then the second shell is L, and it can hold maximum 8 electrons. Then third shell is M. It can hold maximum 18 electrons. And then N, it can hold maximum 32 electrons. And this is being given the formula by 2n square, where n is the number of shell. N is the number of shell. When you put the value 1 here, 1 square into 2, you will get 2. 2 square is 4. 4 into 2, 8. 3 square is 9. 9 into 2, 18. 4 square is 16. 16 into 2, that is 32. But there is one condition. If it is the outermost shell, except the first shell, then it can hold the maximum 8 electrons. For example, let me give you example here. That the potassium is going to have electronic configuration. The atomic number of potassium is 18. Okay. 18. Let me give you an example. That this one is helium. I'm writing here noble gases. Helium. Then next one is neon. Then argon. Then krypton. Then xenon. Okay. The electronic configuration of helium is 2. And that of neon is 8. 2, 8. That of argon is 2, 8, 8. Okay. That of krypton is 2, 8, 18, 8. 18, 8. What happened here? After the argon, I'm going to give you an example. Argon is going to have atomic number. How much? That is 18. 8, 8, 16 and 2, 18. Now the next one is potassium, and it is going to have electronic configuration 2, 8, 8, 1. Why? Because third shell can hold 3 electrons. Sorry, 18 electrons. Then 2 into 3 square is equals to 2 into 9 is equals to 18. So it can hold 18. Why it is coming to the next one? Why it is not coming into this one? 9. 2, why it is not showing 289? Why it is showing 2881? Why? Because it is the probability. It is a rule that you have studied in the previous class, 9th standard, a Bohr model, that the maximum number of electron in the outermost shell can be 8. Can be 8. So in the next one, that is calcium, it will be 288. Okay, 282. Sorry, 2882. Then so on 2883, and then similarly 2887, and then 2888. Then the next one 288. Now it will not be 1 because the outermost shell is already filled with 8. So this electron will come into this one. 2898, 2810, So since the innermost shell can have, third shell can can accommodate more than 8 electrons. So it can have 9, 11, 12 electrons in the outermost shell. And then we're going to study, it will be more clear when you will study the structure SPDF electronic configuration in 11th 12th standard. So it is not being required here that why they can accommodate. They can accommodate because they have the space. They have the space in order to fill the orbit. Okay, the third shell can have.
Sir, Sir, I was already studying it and I got this doubt. That's why I asked for.
You were studying SPDF.
Yes, sir.
Okay, so after the class, I will clear you this one because this is not in the 10th standard. So that is
Sure.
my thing. Okay, but you need to understand this one that after the third period, after the third period means the electrons, the elements with fourth shell atom means after the potassium, fourth shell come in this one. After the potassium, the elements can have more than 8 electrons in their outermost shell. Okay, but during the time of bonding, they can have. Why? Because in case of sulfur can accommodate more than 8 electrons in the outermost shell. Why? This is the expanded octet rule property, expanded octet rule, and this will discuss in some other class, or when we will discussing the bonds like ionic bond. Then I will explain you when I will be going to discussing the valency Then I will
Okay,
explain
sir.
you. Okay, because of d block elements, d block vacant d orbital, vacant, and I'm going to give you vacant d orbital, they can easily hold the electrons, more than 8 electrons on the orbital, because they have rooms, they have orbitals, vacant orbital, vacant d orbitals is present in the third period. So after the third period, a shell can accommodate. Okay, so we will discuss it some other time, and we will going to discuss this SPDF electronic configuration, then we will learn. Okay, but
Okay,
this is
sir.
not in 10th standard, so I'm not going to waste their time, because other student will think we should discuss those first, that is in the topic. Okay, so let's move to the chemical properties of metals. Chemical properties of non-metals. What is the chemical properties of non-metals? That non-exceptions I'm just writing here only. They are opposite as that of metals. If metals are good conductor, they are bad conductor. If metals are sonorous, they are not sonorous. If metals are shiny, they are not shiny. If metals are solid, they are liquid or gas. Okay, means they are also solid, but okay. So there are some exceptions. Let us discuss. The first one is they are generally, non-metals are generally solid or gas, except the one that is bromine. Bromine is the only non-metal that is liquid at room temperature. Okay, so bromine is the only non-metal that is liquid at room temperature. Which metal is liquid at room temperature? Can you tell me? Tejasvi, Shoaib,
Mercury.
Mercury. Very good. Let's move further. That is bad conductor. They are bad conductor of electricity. Generally, they are bad conductor, but there is an exception. That graphite. Graphite is an allotrope of carbon, which is bad conductor of electricity. What do you mean by the word allotrope of carbon? Is there anyone who can explain me this? Allotrope of carbon. Allotrope of carbon. Allotrope of carbon. What do you mean by the word allotrope of carbon? Actually, when we see some elements, like we are just getting the carbon from the earth crust, okay, in the form of coal. Sometimes we get in the form of coal. Sometimes we get in the form of graphite. Sometimes we get in the form of diamond. Diamond is also made up of carbon. So what is that thing that is making the coal, diamond, and graphite different? That is the arrangements of atoms. For example, in graphite, carbon atoms are arranged in a hexagonal pattern like this. Like this. Okay, in graphite, carbon atoms are bonded together in a hexagonal like structure. Okay, like this. But in case of diamond, the carbon atoms are arranged in a tetrahedral structure. A tetrahedral structure like this way. Like a tripod. We have tripod with 3 sticks of tripods and one at the above. So this is tetrahedral structure. Tetrahedral structure. Okay. Tetrahedral structure. Okay, dear students. So this is the actually this is the arrangements of atoms that make coal and graphite different. Graphite and diamond different. Okay. So when we see some elements, we are just exploring some, we are just extracting some metals or non-metals from the earth crust, and only because of the pattern of arrangements, different arrangement. This is the carbon atoms. This is also called carbon atom. Both of them, if you are burning graphite, if you are burning diamond, both of them is going to give you C plus O2 gives you CO2. Their chemical property is almost same. But you need to understand here one thing is that in graphite, carbon atom is bonded in a hexagonal structures, but in diamond it is bonded with tetrahedral structures. And because of this, they are going to have different properties. Like in graphite, each carbon atom is bonded with 3 other carbon atoms. Like you see that this carbon atom, this is also bonded with some other one. This is bonded with 3. This is bonded with 3. But carbon generally make 4 bonds. So one of its electron is free, like this. You can understand. Okay. So this free electrons make the graphite good conductor of electricity. But in diamond is bad conductor. but it is the hardest substance. It is a non-metal, but it is the hardest because of when you apply the force from this direction, it will be distributed in all the direction. It make this hard. For example, if some substance is made up of like this, if I apply the force in this direction, the maximum force will be on this carbon. If I apply, it is also carbon, it is also carbon. If I apply the force from this direction, the maximum force will be on this carbon. If I apply the force on this direction, the maximum force will be on this carbon. If I apply the force in this direction, the maximum force will be on this direction. But in case of tetrahedral structure, this is the specialty of tetrahedral structure, that you see that this one, when you apply the force on this one, the force will be equally distributed on all, in all the directions. It is a tetrahedral structure that the bond angle is between all of them is same. That's why the force distribution is same. So it is the structure, it is the arrangements of carbon atoms that make the diamonds a hardest substance known, naturally occurring hardest substance. Okay, and this is the property of graphite or arrangement of atoms in graphite, that in carbon atoms are arranged in this way, that one carbon atom is making three bonds, leaving an electron free, and that free electron is making the graphite good conductor of electricity. But in in diamonds or carbon atoms, one carbon atom is making 4 bonds, 1, 2, 3, 4. So it is bad conductor of electricity. It is bad conductor of electricity. So we can write here that bad conductor of heat and electricity except the graphite, which is an allotrope. What do you mean by the allotrope? We will discuss this one. What is allotrope? Allotropy in carbon compound chapter, but we can simply say that the existence of an element in different forms due to different arrangements of atoms. If they are arranged in some different manners, like in diamond in tetrahedral structure, like in graphite in hexagonal structure, so these are the same elements, that is a carbon, but the arrangement is making different in their physical properties. So simply we can write here that except graphite is a good conductor of electricity. Okay, is a good conductor of electricity, and diamond is good conductor of heat. Okay, diamond is good conductor of heat, but bad conductor of electricity. Next one is brittle. Brittle means that they can be broken, easily broken. They are easily brokenable, but diamond is the hardest naturally occurring substance. Okay, diamond is naturally hardest occurring non-metals. Okay, why? Because of when you force it, this force is distributed in all the carbons equally. That's why the force is being distributed. None of the carbon is going to have maximum force. All of them going to have the same force. That's why we can simply say that. Diamond is the hardest naturally occurring substance, and it is a non-metal, but still it is hard. Okay, got it? When you hammer the diamond, it will not break. Got it? Everybody understood?
Yes, sir.
So please make a note of this. Done?
Yes, sir.
Yes, sir. Yes, sir. Noted.
Okay, very good. Very good. Proud of you. So in the next class, what are we going to discuss? We will going to discuss the chemical properties of metals. First, we will study the metals, okay? Then we will study the non-metals, the chemical properties of non-metals, okay? So we have in today's class, what we have discussed, that what are metals and what are non-metals according to their electronics structure. That metals are those elements that is going to have 1 or 2 or 3 electrons in their outermost shell. Non-metals are those that is going to have 4, 5, 6, 7 electron in the outermost shell. Okay, what is ionization energy, chemical properties, physical properties, and their exceptions of both metals and non-metals. So in the next class, we're going to discuss the chemical properties of metals and their ionic bond formations. Okay, metals and the bond formed between metals and non-metals. Okay,